Basically, this is a process that we can use to do factoring. Normally, when an expression has 4 terms like this one, we would look at it and maybe try to do grouping. But because there is nothing here that we can pull out in the form of a common term, we can't use grouping. So what we do is we try to find a factor that we can use. Now, your book says to start with 1 and try 1, and then try -1, and then try 2, and then try -2. That would take forever, and we actually have some tools that we can use. One thing that you can do is you can take your function and you can graph it. Now, I've graphed it in 2 different places. I've graphed it on our TI-84 because a lot of you have that, and I've also graphed it using Desmos. So let me pull those up and let you see them. This is my graph from the TI-84. I just hit y equals, and I typed my expression in there. And you can see by looking at it, if we look at this, we can see that it appears that there's a 0 there. Remember that 0 is where the graph crosses the x-axis, and this is the x-axis. It looks like there's a 0 there and a 0 there. This one actually looks like a 2. So make note of that, and you can decide that you might want to use a 2 with our problem. Now let's look at the one with Desmos. Now this one is my graph from Desmos, and you can see the 0's here and the 0's here. So a 2 is a pretty good 0 to use. So I would go back to my problem, and this is again just from graphing this function. So I've looked at both graphs, and I can see that 2 appears to be a good 0 to use. So I will take that 2 and I will use synthetic division to show that it actually is a factor. So I'm going to take all of the coefficients here, and I'm going to do synthetic division. So I'm going to pull down my 1. 1 times 2 is 2. 5 and 2 is 7. 7 times 2 is 14. Minus 2 plus 14 is 12. 12 times 2 is 24. Minus 24 plus 24 is 0. So this is a 0. So now I know that I have a 0 of 2. I also have a function here that I can use. This started with a 3, so my current function will go down to an exponent of 2, and these are the coefficients. So this would be 1x squared plus 7x plus 12. Now this is normally something that you should be able to factor, or you could use the quadratic formula if you wanted to because it's quadratic. I can look at this and I can say there are factors of 12 that add up to 7, which would be 4 and 3. So I can factor this into x plus 4 times x plus 3. You might need to do some more practice on factoring if that's not part of your background. So we have this one factored. We have a 0 here that we found, and it came from the expression x minus 2. That's how we got the 2. So our fully factored function is now x plus 4 times x plus 3 times x minus 2. Whatever 0 you started with, you just go backwards to get the factor that it came from. So this is the factored version. So x plus 4 times x plus 3 times x minus 2. Our zeros are minus 4, minus 3, and 2.